Okay, back with the OCR paper. This is the 2019 Maths and Mechanics. I'm looking at question 7 now. Nice little graph questions. Let's look what's going on here. So I've got this graph here, and I'm trying to find the area of both these regions. Well, the first thing to recognise is what these points are here. This is going to be when y equals 0, and when y equals 0, x can equal 1, so that's 1, and x can also equal 5, so that's 1 and 5 on our graph. So we need this integral between 1 and 5 for the curve, and then we need this area here, but we've got to remember that this area here is going to be negative because it's underneath the axis. So we don't want the negative version when we add these together, we want the actual positive version. So I think what I'll do is I'll work out this area, separately, and then I'll make it positive and stick it on, and then we'll see where we go from that point in. Now the question says, the diagram shows the curve, so it's just telling me what it is, and it tells me the area is going to be 19 when I finish all the messing about, and I've got to find the exact value of A, which probably means I'm going to avoid using a calculator, because you lose accuracy as soon as you use calculators. And it's an 8-point question, so there's quite a lot of work to do. So let's go with the question then. So it's the integral. So the first section is 1 to 5 of 5 minus x, and then x minus 1 with respect to x. That's the first section. Now I'm just going to expand that bracket out, so 1 to 5 of, expand the bracket out, what we're going to get. So we're going to get 5x, so let's just write that up, 5x, we get minus 5, we're going to have a minus x squared, and we're going to have a plus x at the end. And then, so with respect to x, is our integral, so that's equal to the integral between 1 and 5 of 6x, and then you've got a minus x squared, and you've got a minus 5 as well with respect to x. Okay, so that's where we starting point. That's the starting point for this question. I'll just leave it that way around because I don't like negatives being at the front. Normally you write the x squared first, but I just don't like that negative. So integrating, so we just go integral, it's a definite integral, so we don't have to worry about the constant integration. So add 1 to the power becomes 2, divide by the new power becomes 3, so it's 3x squared, take away 1/3 of x cubed, add 1 to the power, divide by the new power, minus 5x between 1 and 5. Okay, I don't need to whack the numbers in there, so that's going to be equal to, in square brackets now, so we've got x squared is 25 times 3 is 75, take away 125 over 3, take away 25, so that's just running the 5 through. Now I run the other one through, but remember to take away, so you've got 3, take away 1/3, and then take away 5, and that's just running the 1 through. Okay, we can tidy this mess up to get 50 minus 125 over 3, but then we need to, what's that, that's going to be 3, take away 5 is minus 2, but that minus makes it a plus 2, and then the minus and the minus also makes it a plus, so we've got plus 1/3, so that's going to equal to 52, and then minus 125 plus 1, both over 3, is minus 124 over 3, which equals, now we've got to make them both over 3. I'm trying to avoid using a calculator. I could just use a calculator to work this out, but I'm just going to show off. That's equal to 352 is 156, take away 124, all over 3 now, which equals, what's that, 32, so 32 over 3. So the area, what we're saying now, we're saying this area here is 32 over 3. So now I just need to work out this area down the bottom. And pause the video because we've got people walking in. Resumed. Okay, so now I'm going to work out this integral. Remember, it's going to be negative, or we should have a negative value when we finish the job. So it's the same setup. So we're going to go with, I'm probably going to need more paper, aren't I? So I'll just do a separate piece of paper from the start. So we've got the integral, and it's from 5 to across to A. Okay, and then the equation turned out to be, was 5x minus 5 minus x squared. No, it wasn't, it was 6x, wasn't it? 6x minus 5 minus x squared with respect to x. Okay, I actually had these two the other way around last time, but for some weird reason I wrote them that way around this time. So that's equal to, in the square brackets now, so integrate, we've got, add 1 to the power, divide by the new power, 3x squared minus 5x minus 1/3 of x cubed, and this time we're between 5 and A. Okay, so now I just need to run the numbers, so let's run the numbers through it. So we've got 5 times, well, it's 5, doing an a through first, only 3a squared minus 5a minus 1/3 of a cubed, and then take away, so it's equal to that, equals, and then you got, what's that, 25 times 3 is 75, we've got 5 5s are 25, take away 25, and then take away 125 over 3. Okay, let's just get this a bit tidier. So it's equal to, so 3a squared minus 5a minus 1/3 of a cubed. Can't really do anything with all that lot. That's what's going to be 25, but it's take away. So take away 50 even. Can't do takeaways. Take away 50, and then the minus becomes plus 125 over 3. So that's the area of the bit that's underneath the curve, right? So now I need to add on the original area. The area worked out earlier, 32 over 3, to this thing, but remember this is negative, so I need to change all these signs to make it into positive, right? And that's making it go above the graph, and that should equal 19 eventually. So let's have a look. So now we've got 32 over 3, then we're going to take away 3a squared, we're going to add on 5a, we're going to add on 1/3 of a cubed, we're going to add on the 50, but we're going to take away the 125 over 3, and that's got to come to 19. Okay, looking at all this mess, what can we do? We can sort out certainly these two bits, the third bits, and just leave everything else alone. So we'll do a bit at a time. 3a squared plus 5a plus 1/3 of a cubed plus the 50, and we'll just sort out that one. So 32 from 125, what's that? That's going to be like 93 or something. So 93 over 3. Oh, 93 over 3, so that's good. So let's take away minus 93 over 3 equals 19. 93 over 3 is obviously 31. So we've got minus 3a squared plus 5a plus 1/3 of a cubed plus 50 take away 31 equals 19. Well, look at that, that's 19, isn't it? Minus 3a squared plus 5a plus 1/3 of a cubed plus 19 equals 19. So now the two 19s are going to go away. So let's keep going. So we've got minus 3a squared plus 5a plus 1/3 of a cubed equals 0. Let's times everything by 3. So we've got what have we got? We've got, so I'm going to put them in the right order. I'm going to move that to the front as well. So I've got a cubed times everything by 3, remember. Take away 9a squared plus 15a equals 0. Factorise. A into a squared minus 9a plus 15 equals 0. Now sort out this mess, which is going to be a bit of a headache because it doesn't actually factorise now, does it? So this doesn't factorise, so now I'm probably just going to go to the quadratic formula, hopefully, and sort out with that one. So I've got minus b, so the quadratic formula. So a is either 0, which you know it can't be because it's beyond 5 for a start. And then we've got, resumed. Okay, so it can't be 0, so that one can be discarded. So now I need to just solve this one. So I've got a equals, this is for the formula, not that a equals 1, b equals minus 9, and c equals 15. So the a, our proper a, is equal to minus b, so minus 9 plus the square root of minus 9 squared minus 4 lots of a's, lots of c's, all over 2 lots of a's, which equals 9 plus and minus, that should be in plus and minus, the square root of 81, and then minus 4 times 15 is 60, all over 2a's, all over 2, which equals 9 plus the square root of 21 over 2 plus and minus, right? So we've got the values there, 9 plus and minus over 2 for our a. Now, when you get your calculator should be able to help you out now to figure out which of these two versions we have. Remember, a has got to be bigger than 5 because of the way the graph was drawn. So what we got, I've got 9, let's do 9 plus, oops, I'm going to fraction first, 9 plus the square root of 21 over 2. So when we do the plus version, you've got 9 plus square root of 21 over 2 is roughly equal to 6.79, so that looks promising. And 9 minus the root 21 over 2 is roughly equal to, so just get the calculator, go back over and change the plus to a takeaway, and I've now got 2.20-ish, and this one can't be true because we know it's bigger than 5. So A eventually is equal to 9 plus the square root of 21 over 2, game over. 8 points. Alright, stop on that.